apply them to a graph. So in chapter 3, we only counted, ladies, are you guys with me? Amber, Megan, Amber, Megan, Megan, Amber. In chapter 3, we talked about how many x-intercepts. Now in chapter 4, we're going to find the location of those x-intercepts. So, okay. What is the y value at an x-intercept? 0. So we know that anytime we're solving for an x-intercept, we know that y is always equal to 0. Okay, so the first thing we're going to do is we're going to set our quadratic function equal to 0. And the reason why is because we're looking for the x-intercept. So we know the y value is 0. We're going to factor the trinomial. We're going to set each factor equal to 0, and we're going to solve for x. And that will be the location of our x-intercepts. Okay, so you guys know how to factor. Easy peasy, right? What are the factors of -3 that add up to a +2?
-1 and +3.
All right. So 2 different ways to do this. So if I have 0 equals x squared plus 2x minus 3, and you guys told me that the factors of -3 are -1, +3. If you guys prefer to do it this way, you can. And then we look at the front two, and we're going to common factor something out, and I'm going to take out an x, so I'm left with x plus 3. I look at the back two, I'm going to common factor out a -1, so that's going to leave me with x plus 3. So my two factors are going to be x plus 3 and x minus 1. This, sometimes I won't call it lazy, I'll call it efficient. But this only works for simple trinomials. And I've got lots of experience doing it. If I was not confident in my factoring, I'd probably always go to this way. But with simple trinomials, when we talk about simple trinomials, that means that the coefficient on the x squared is a 1, a positive 1. We can go right to here. And sometimes I'll do that. And I'll get those two numbers from the factors. Okay, so that's a quicker way to do it, but I need to say this out loud. I'll say it a million times. It only works with simple trinomials. So the a coefficient is a 1, a positive 1. Okay, so now that we've factored, and if you don't believe me, please note we did all the steps and we got the exact same factors. So after we factor, so we factor the trinomial, we set it equal to 0. Yeah.
So you know how our x-intercept does the opposite of what it's supposed to do? So is the -1 actually a positive one, or is it -1?
It's a positive 1.
Oh. And
Yep.
3 is -3.
Yep.
Oh.
But this is how we're going to do it. We're going to set each factor equal to 0. So we are going to set x minus 1 equal to 0, and we're going to set x plus 3 equal to 0. And then we're going to solve for x. So if I want x by itself, I'm going to add 1 to both sides. So x is equal to 1. And then I'd have to minus 3 from both sides. So x is equal, to a -3. Now, you do not have to show me this math. You don't have to show me this step right here. But those are the location of my x-intercepts. Okay. We're going to graph this parabola. What else do I need to graph a parabola? The vertex. Can somebody find me the vertex? Are you going to use completing the square, or are you going to use secret formula? Go forth. Find the vertex. So I use the secret formula and I get the vertex at -1, -4. Anybody complete the square? So when I complete the square, I get the same answer as well. So method 1, secret formula. Method 2, completing the square. It really depends on what you feel the most comfortable with. And you might not feel comfortable with either of them yet, and that's okay. But I would suggest you pick a method and stick with it and learn it really well inside and out. Like, I do this every year, so I'm fine with going back and forth between them, but I get really good at one. And if you want to dabble in both, that's great. So we know our vertex is at -1 and -4, and I showed the math for that. Okay, so let's talk graphing here. I need to label my increments. So I'm going to go anytime you're graphing in pre-cal, it should be done on graph paper. I don't know how to tell you more plainly than that. We're all about accuracy in pre-cal, and trying to draw one out on a lined piece of paper is going to be really difficult. If you're a good visualizer, you don't have to put the increments on each one. You could just put them like the most max and the most min. You could do that. I suck at that. I have to see each tick labeled. That's just who I am. Okay, so I'm going to graph the 3 points I know. I know I have an x-intercept at 1. I know I have an x-intercept at 3. And I know I have a vertex at -1, -4. Do I need to graph more points in this? Probably not. I think I'm probably good here. I've got some critical points labeled or marked on my graph, and now I got to connect them with a smooth curve. And we need to make sure we label 2 points. Arrows on the tops to say that we can continue going on forever if we need to. And should this graph have opened up? You can tell that from the equation. Should it have opened up? Yes, and we knew that from that value there was a positive one. Everybody good? Okay. Complex factoring. We did this in grade 10, so not a ton of stuff for us to do here, but you got to practice it. So the first step in factoring a complex trinomial. Complex just means it's got a number other than 1 there. So this one has to have a 2. So I'm going to take the 2 and I'm going to times it by the -5. So I'm looking for the factors of -10 that add up to a -9. 10 and 1. So I'm going to have a -10 and a +1 because I need a -9 there. And your guys' factoring practice, those of you who handed it in, did an amazing job on it. Like a couple of mistakes here and there, but you guys worked obviously really hard in grade 10 and really understood the factoring. Okay. So you keep this front term. That just gets rewritten. Then we're going to rewrite the -9x with those 2 factors. and that guy gets just repeated as well. So those two don't change. Those two don't change. And I just want to point out that if there's an equal sign in the question, you should have an equal sign all the way through. Like, don't drop your equal sign. That's bad, oh bad. Okay, same thing. I'm going to look at the front here. I can take out a 2 and I can take out an x, so I'm left with x minus 5. And if I look at the back section here, there's nothing to common factor out. Like, there's no x's, there's no common numbers. So I'm going to take a positive 1 out. And that will just leave me with x minus 5. And so my factors are x minus 5. And if I cover over those two, what's left over is 2x plus 1. So that's my other factor. If I have an equal sign set equal to 0, I'm going to go ahead and solve now. So I'm going to say x minus 5 equals 0. And 2x plus 1 equals 0. I didn't show my algebra on that. Are you guys okay with that? Nobody's screaming no. Okay, the next one, before I even get started, I got to do a little bit of math. I want to set it equal to 0. It has to be equal to 0. So I've got to bring this guy, the negative 12, to the other side. So I'm going to add 12 to both sides. So I'm going to have 18a squared plus 42a plus 12 equals 0. What's 18 times 12? A number that I don't want to deal with. Do you guys notice anything about the numbers in this?
All divisible by 2.
They're definitely all divisible by 2. Are they divisible by a bigger number? 6. So you can common factor out a 6 out of all of them. So if I take a 6 out of all of these numbers, I'm going to be left with 3a squared plus 7a plus 2. What's 3 times 2? 6. Isn't that a nicer thing to do? If you can common factor, please do it. If you can common factor it out. So now what we're looking at is we are going to factor this trinomial, but this guy has to follow us through every line. So I'm going to take 3 by 2, and you guys told me that was 6. What are the factors of 6 that add up to 7? Oh, brilliant. So the 3a squared gets just rewritten. It's the 7 that we're rewriting, so I'm going to say plus 6a plus 1a plus 2. So that 3a gets rewritten, that 2 gets rewritten. That 6 has to follow us down, because the idea is if we were to multiply it all back together, we'd get right back to that top question that we started with. So you can't forget that 6. Is it going to be helpful to us? Not at all. But you can't forget them. Look at the front two. I'm going to take out a 2a. No, I'm going to take out a 3a. Look at the back two. There's nothing common there, so I'm going to take out that 1 again. And that just leaves me the same thing. So I've got 6a plus 2, 3a plus 1 equals 0. All right, so I'm going to set each factor equal to 6. Or equal to 0, sorry. 6 equals 0. Is that a true statement? No. I really don't even need to do that stuff. That's not, because there's no variable to solve for. So I'm going to have a plus 2 equals 0, and I'm going to have 3a plus 1 equals 0, and I've left myself no room, so I'm just going to solve them over here. A is equal to a negative 2, and A is equal to a negative 1/3. So those would be my A-intercepts or my X-intercepts, whatever you want to call them. Horizontal intercepts, horizontal axis intercepts. Okay, people super struggle with this. Super struggle with this, and it's not terrible. It's not terrible. It's easy. In the end, when we're doing difference of squares, so difference means subtract. Squares, we're looking for perfect squares. We're looking for perfect. And you guys know the perfect squares, right? So when I talk about perfect squares, I'm talking about 1, 4, what else we got? 9, 16, 25, right? But also a perfect square is x squared, because two factors that multiply together to give me x squared is x and x, right? So if we were to take the square root of x squared, which you have done a million times doing Pythagorean theorem, and no one worries about it then. So really, if you know the square root of 25, you should know the square root of x squared. So with perfect squares, you have two binomials. One's going to be a subtract, one's going to be an add. You take the front term, you square root it. What's the square root of x squared? X, so an x goes here, and x goes here. What's the square root of 25? What? It doesn't matter, because you're multiplying, that you can switch them. Yeah, doesn't matter. Okay? Is this a perfect square? Is 4 a perfect square? Is x squared a perfect square? Is 25 a perfect square? Is x to the exponent 4 a perfect square? Yeah, it is. Good job. Okay, so again, if everybody's a perfect square and they're separated by a subtraction sign, I'm going to have two binomials. One's going to be an add, one's going to be a subtract. Notice I did subtract first and then add. You can switch those up. It doesn't matter, just as long as one's positive and one's negative. What is the square root of 4? Brilliant. What's the square root of x squared? X. What's the square root? Oh, we just did this. 5. 5. And what is the square root of x to the exponent 4? X squared. You guys are so smart.
We have to put equal 0 there.
Oh, we do. Oh. We're not gonna, well, I guess we could solve them if we wanted to.
Do we?
Nah. Oh, you know what we should have done first? We should have common factored out an x squared. That's what we should have done. That would have saved us time, but it's okay.
Is it wrong if we don't?
No, it's okay. I'm not fully factored here though. This isn't fully factored. Because what can I take out of this one? If I look at that first binomial, what can I take out? An x, right? I can take out an x. What can I take out of here? Also an x. So if I took an x out of here, I'd be left with 2 plus 5x. And if I took an x out of here, I'd be left with 2 minus 5x. And that would be x squared. 2 plus 5x. 2 minus 5x equals 0. That's fully factored. I'm going to do example 7 first, and then I'm going to go back to example 6. Example 7. Perfect square, life's good. And that's equal to f of x. So if I do that one, that's all fine and dandy, but I'm not fully factored. There's a difference of squares hiding in here. This one I can't factor because it has the plus sign in between it. So that one just stays. And this one gets split into the two binomials. And if you can recognize the difference of squares, it's going to be super helpful for you as we move forward in the math. Okay, let's solve this one for a second, okay? I'm going to take this one and I'm going to solve it. So I'm going to have x squared minus 4 equals 0. You with me? So then I got x squared equals 4. And then how do I find x? I'm going to square root both sides. Okay, you with me so far? That's good. Let's solve this one. Can I square root a negative number? No. Your calculator will say error. There are no two perfect factors. There are no two exact factors that you can multiply together to give us a -4. Like one would always have to be positive, one would always have to be negative. So you can't square root a negative number. So that's why you cannot continue factoring that x plus 4. Okay, let's go to the really complicated one. Is that a perfect square? Yes, it is. Is 1 a perfect square? Is 4 a perfect square? So therefore, 1/4 is a perfect square. Yeah. A squared we know is a perfect square. Is 5 a perfect square? But it kind of is. Any number can be a perfect square. How do you like that? You guys are like, no, thank you. I don't want to know this. So I'm going to have 1/2 a, 1/2 a. And I won't give you this question, but I'm just going to do it for funsies. What's root 5 times root 5? 5. What does that equal? Equals 5. Because really, isn't this saying root 5 squared? And then that cancels out that, and then we're left with 5. That's a big stretch. Okay, guys, that's a big stretch. I'm not going to ask you to do that. I just want to show off my math. It can happen. You won't get questions like this. Don't worry. Don't worry. We are going to do a bunch of work with radicals anyway. So, fun times. But that's not coming up until chapter 5, I think. Okay. Let's do some word problems with factoring. These ones really freak people out, but it's easy. It's not easy. Nobody wants to factor this. So a person's body leaves the end of a water slide and it follows a parabolic trajectory. Trajectory is the hard word. Do you guys know what that means? So you're going to leave a slide. You're going to leave a slide. Your body's going to go up in the air. I guess we're not coming this way. You're leaving the slide. So that's your slide right there. Your body's going to go up in the air and then it's going to come back down and it's probably going to enter the water. If you've ever taken a water slide, you go up and you come back down into the water. So we know that this one opens down because it's a -1/6. And it's asking how far does the slider travel before entering the water? So if their journey started here, how far did we go? So we have to find, it's talking about the x-intercepts. Because we want to know when it comes back down. So this would be distance and this would be height. So how high do you go and how far do you go? There should be a D in here, not a T. Let me flag that for me to fix. All right, So we're gonna find the x-intercept. So I know I gotta set my equation equal to 0. And this looks really daunting because you're like, I can't factor this. This is terrible. But before I factor it, I'm gonna go ahead and I'm gonna common factor out a negative 1/6. So if I common factor out a negative 1/6, I'm left with d squared plus d. And really the act of common factoring is you're dividing by that number. So if I take 2 and I divide it by a negative 1/6, what do I get? Negative 12. Yeah. So now we're just looking at, just like we did in the last one, we're looking at this one to factor. What are the factors in negative 12 that add up to a positive 1?
Wait, I didn't understand how you got the 12.
We're common factoring a 1/6 out of all these numbers. So negative 1/6 divided by 1/6 is 1, 1 and 1. And then I took the 2 and I divided it by 1/6. So that would be 2 times negative 6 over 1. So that gives us our negative 12. Okay, so I'm going to set each factor equal to 0. So we know that our parabola comes, if we were to follow the math, it would, you guys can't see my picture, comes back down here. This one's at a positive 3, this one's at a negative 4. This one doesn't really exist. It exists in the pure math, but it doesn't exist in the contextual math of water slide, because your journey is going to start at 0, because you're still on the slide at this point. So you are landing, how far?
Was
Because that's the one that matters. This one doesn't exist in the context. Well, can you have a negative distance? No. Because nowhere on the signs back to Thompson does it say negative 752 kilometers. Although I might go paint signs on it, but you know, negative signs. Don't tell them it was me defacing the signs. So you got to think about it in the context of what's happening. I usually draw a little picture to help myself. That helps my brain a little bit. If I'm asking for the maximum height, what would I be looking for? Would I be using the x-intercepts or would I be using the vertex? Vertex. So if I talk in anywhere in the question, if I'm talking a maximum or a minimum, what am I looking at? The vertex. Okay? All right, so example number 9. The area of a rectangle. Okay, how do you find area of a rectangular? And we know that the area is 45. Oh, sorry. The length of the table is 4 feet more than the width. We know that this whole thing is 45. And we know this length is 4 more than the width. Do we know what the width is? No. We'll call it W, just for easy's sake. So this is the width plus 4. Lots of people put L plus 4, but that wouldn't be right. It's 4 more than the width. So it's the width plus 4 feet would be the length of the table. So we know that that is equal to the length. So this is like almost like a max-min problem, but we're not maximizing it. We already know what the area is. So L is equal to W plus 4. Our width is still our width. What should I do here?
factor.
Not yet. One step before we get a factor.
Okay.
What does it have to equal? 0. So we got to bring that 45 to the other side. I'm skipping a lot of math today. Maybe it's because it's a Friday. Maybe it's because I'm just crazy like that. So I'm going to factor. What are the factors of negative 45 that add up to 4? Anybody? 9 and 5. So if we have a negative 45, I want a positive 4, so I'm going to have a positive 9, a negative 5. Okay, I got 2 answers here. Which one makes sense in the context of this situation? The one that equals the positive number, right? Like the one that equals 5. Can I have a width of, if I said, okay, I need you guys to measure negative 9 feet. Can you do that? So we're going to reject this one, not because the math doesn't work on that one. We're going to reject it because it doesn't make sense in this particular situation. So my width is 5 feet. What's my length? 9 feet. Because we know that the length, is 4 more than the width. So we just took 5 and added 4 to it. That's it. That's all. Friday lesson. Factoring in relation to x-intercepts